Good evening.
Good evening, sir.
Good evening, sir. Hope we are all
Good
doing
evening,
well.
sir. Yes, please,
Yes,
you are fine, my great.
Yes, please. We are fine.
That's great. Philip, now you want to record the session. It's already streaming live on YouTube, and you can get a video from there. So I think you shouldn't waste your space. But if you still don't mind, you can say you don't mind. I can allow you to record.
We don't mind.
Are you Philip now? And you are with
No,
him?
it's Jasmine.
Jasmine, you are with Philip now?
No, I'm alone.
Oh, okay.
Sir,
Or
please, I
you
don't
also
mind.
record because he's the only one who has requested to record. Okay, like I said in a chat platform before the meeting, we are going to model actually single product CVP assessment with Python. So simple to do. We have the concepts. We have the whole of how the tool works. So what is left is we're just going to plug it into Python, and we have fantastic understanding of how Python also works. So I think I'll begin this lecture by making some of you attempt the modeling exercise. I think it will be fantastic that way. So those of us who are willing to do that, you can let us know so you can share your screen with us. If we make it that interactive, I think it will bring a lot of learning. It will bring all the things in us out. So if you are ready, if you are willing to do that, that will be experimental. We are not going to mark anything. We are experimenting. So everybody should feel free. We like people to make mistakes. We like the mistakes. So if you are willing to show us your mistakes, and I think I should be giving marks for the mistakes. The one who make more mistakes get more marks. Yeah, so that's how we're going to do it. Who is prepared? And I have some marks to dash for that.
I said,
It's,
when is it starting?
hello? Who is talking? I didn't hear what you were saying. Please come again.
Sir, please, we didn't get what you said earlier on.
Earlier on, I said I want this session to be very interactive. So what I want to do is that I want us to be experimenting together, as opposed to the traditional style where I'll be doing it and you'll be following it. The reason why I want us to take that approach is that we have a good understanding of the concept of CVP, single product. And we have also experimented a lot with Python. We have done a lot of things that are around this kind of modeling we are doing. So I think it is a good time that we try to play with the things we have learned. And we are focusing more on the mistakes. Those who make more mistakes are the good people. I'll give them marks. So if you want to show us how you are attempting to do that, we count the mistakes you'll be making, and that is how you get your marks. I have some marks. I won't mention the marks, but definitely I'll award marks. So if
Okay.
you are motivated to get a marks, forget about the mistakes because the marks is actually driven by the mistakes. Then you can show your screen. Who is sharing these screens? There's a screen showing currently. Who is doing that? Someone has shared a screen. The person should unshare the screen, please.
Who is sharing?
Who is Michael Adam?
Who is my girl?
Who has shared his screen? Just unshare it, simple, please. Okay, so who wants to kind of experiment? Who is ready to experiment something?
So Solomon.
Solomon. Okay, Solomon. Just
Yeah.
on your screen, I think you can see a button which has the inscription share screen. So try and share your screen and see if it will come.
Okay, sir. How I will share. Sir, please. Sir,
Yes, please go ahead.
I'm currently having a problem with my laptop, so like I want to fix it before. Like I want to restart the laptop.
So you are not ready. I'm talking about who is ready. Who is ready to share the screen and just experiment with the modeling? Okay, good. 10 marks, and it's like you are way off in your continuous assessment. 10 marks is on the table. Who wants it?
Hello, sir.
Yes, please.
Sir, please, you said we are
Yep.
supposed to share just the screen.
What else
Hello?
did you want to share? You can share anything you want to share.
Okay,
But
sir. Thank
we
you.
can only see what you are doing when you share your screen. So that's the meaning.
Okay, thank you.
What I mean is that share the work you are doing with us so that we can see what you are doing because you are modeling and we want to follow the modeling. Is that okay?
Yes, sir.
So share your screen and let's go ahead. Yeah, Ima. Hey, Andrews, please be bold and share your screen and try, okay? We are all trying. That's how we learn. Have you seen where you can click to share your screen? Okay, so let's go ahead. I am going to share my screen with you. I see nobody wants the mark, so I'm not going to worry you about it.
Hello, sir. Please, I'd like to share.
Yes. So share it.
Sir, please, sir, you've disabled the screen sharing ability. Hello, sir.
Yes, okay. Let me
Yeah, they said host disabled participant screen sharing.
please try it and let's see.
Okay, sir. I don't know which one to even share.
At the bottom of the
Okay, sir.
screen. Okay, so go ahead.
Please, the screen is shared.
We can't see it. Okay, yes, it's shared. We can see it here. Latin Elvis. Alfred, put that name down for me. So please, you can go ahead. And be bold, okay? It's not about the mistakes. The mistakes are Harriet Fosu. Why are you scratching the screen? So it will be good to be talking about what you are doing in terms of an explanation so people can understand it.
Okay, sir. So the first thing we have to do in relation to data analysis is we import some of the packages that Python comes with. That is NumPy dealing with the numerical data, and pandas and seaborns. Pandas to help us with the data distributions, and also seaborns and PyPlot to help us with the graphical representation.
So please go ahead. We are waiting for you. Yes.
Please,
Hello, sir.
Please go ahead.
Hello, sir.
Yes, please.
Please, can I continue?
Of course, you have the
Okay.
floor, so just go ahead. You don't need me to tell you what to do.
Okay. So we can all realize that because of the misspelling of the seaborn, that's why we have this error here. And it's even indicated here showing us there's a problem with this spelling. So I've created it and I'm going to run it again. And after I'm done running, though this shows that this one here shows that this cell has been run or there's a run cell already. So when I run it again,
Okay, so I think it's a good attempt. Now, disable host them sharing screen. I'm going to do it. So I want to share my screen so that we can. It's a good attempt, and I think everybody should be willing to do that. That's how you learn. You don't learn by always listening. You learn by doing it, especially with hands-on subjects like programming. Okay, so let me share my screen. And like he was helping us to understand, we begin by importing the usual packages. And these are the packages that you usually need when you have any data analysis task. And they happen to be these usual suspects: NumPy, Pandas, Matplotlib, Seaborn. For what we are doing, we are not going to do any statistics thing, so we might not necessarily need stats models. It's just for statistics. If you want to do some regression or something around that, then we might need to import that package. So we are good to import NumPy as NP, but you can import it as any other alias. We just want to maintain the industry practice of using the shorthand NP for NumPy. Import pandas as PD, import matplotlib.pyplot as PLT, that's the tradition. Maybe we will need Seaborn. I mean, we can import them just in case we need it. Import Seaborn as SNS, but you can import it as some other thing if you prefer that. So I think for this project of modeling CVP, these packages are okay. We will not need the stats models because we're not going to do any statistical modeling. So once I'm done, then I need my variables to be created. The variables I'll be manipulating to create the model. I need it to be created. So we need a question from which we need to, or we need a case which we want to model. I just want to give some brief background about some example I used to teach the finance, I think the finance group, and then one of the accounting groups. Coincidentally, when I wanted to introduce the concept of single product CVP, I needed some sample product, which is a single product which you yourselves as students, you trading, you buy and sell sort of. So one lady talked about the fact that she is in the business of selling scrunchies or something. So we use it as an example. I think in one of scrunchies, okay. One of the accounting groups and then the finance group. And I guess for the ladies, all of you know about the scrunchies. If you're a guy and you don't know about it yet, I showed it in class just for everybody to know about it. If you don't know and you have some girl beside you, you can ask her. Maybe she even has one on her head. She can just show you directly. So it's a simple product. And the statistics I took from class was like Of course, the statistics were different between the two classes. One said she sells her own for 5 cedis, and then she buys it at 3 cedis. And the other one said she sells her own for 10 cedis, and she manufactures it herself. The manufacturing cost is approximately 5 cedis. So we can use any one of them. And the 10 cedis one, when I asked her about why hers is 10 cedis and others are 5 cedis, she said, like, they have different grades. So that grade is for 10 cedis. So we can decide to choose any of them. The fact we want to establish is we are talking about one product. The company sells only one product. The business sells only one product. And most of you students are into that kind of business already. So as you are doing this, you try to employ the tools, the techniques to your business. Otherwise, forget it. If you're not learning to do that, then what you are learning will not be useful for you and for anybody. We learn these things to use them. And that's the difference between businesses doing well and businesses not doing well. You don't take decisions by intuition or by prayers. You take decisions by what the data is informing you. That is what we call data-driven decisions, as opposed to instinct-driven decisions. So that's it about maybe the business that we will be using to experiment with this modeling. But before I start the modeling proper, maybe let me give a brief background about what this tool called CVP is all about. CVP, which stands for cost, volume, profit analysis, is basically how we look at the interaction between costs of our business, any profit we imagine to get, and how we can determine the profits given our costs from the volume. So it's like 3 variables are playing. We can find which volume gives us which profit, given that we have this cost. Most of the time, the cost is even given by the market dictation. You don't have your own market, which you buy your products at your own cost. You buy from the market, so the market dictated price. So the cost is mostly given. So with a given cost, which in our modeling, we are going to concentrate on variable cost, fixed cost, with a given cost and with some target profit, which volume. So this is my cost. And I want these profits. Which volume do I do to get that? So that's what the tool helps you to gauge, basically. Okay, so with that understanding, I think we can go ahead. And then we have done a lot about the concept in the classroom, so you shouldn't have a problem. If you are still struggling, you can watch the videos. The textbooks are ready. You will get them here on Thursday. And we have fantastic content in the textbook to help you understand these concepts. And all the other concepts we'll be talking about in the semester to understand them very well. Okay, so let me go ahead. After the importation of my usual packages, I need to create the variables. What we have learned in class is that, of course, when you take your mind back to when we're trying to extract the formula from the income statement equation, we came to the realization that the tool revolves around some key parameters like selling price per unit. So let me set it up straight away. Selling price, sorry. Per units. And let's say maybe the 10 cedis one, it doesn't really matter. So the selling price per unit is 10. He sells one for 10. And then she said variable costs. per unit is 5 cedis. And then we try to deduce an amount for total fixed cost. She doesn't seem to have any real fixed cost except the place of selling. And at the moment, she sells it from her hostel. So based on the business entity concept, if you like, the artificial personality concepts that you learn in accounting and law and so on and so forth, we can say that the business is a person and that the business should pay for its costs as it incurs its revenue. So the business is sharing the room with that young lady who gave us that example. So we asked her to give us an idea of the cost of the room and the realistic portion which the business should pay for. And I think she came up with an estimation of 500 cedis. So let's use that just for an experimentation. In real world business, these figures will change and figures keep changing. So it's not really the figures. It's about the principles. So let's say total fixed costs is, as she said, 500. So with this variables, then we can go ahead and create our model. We'll first create a model in a tabular way, which will give us a sense of, okay, if we have this quantity, this is the corresponding profit. We can even trace all of those other statistics. This is the corresponding total variables cost. This is the corresponding total cost. This is the corresponding total revenue. This is the corresponding profit. We can do it across several quantities so that we can say, okay, this quantity brings this quantity brings it, this quantity brings it. So when we study that kind of model, we can see that, let's say in a semester or in a period, we are targeting maybe for a student 1,000 cedis for your profit in the semester. You will have to match that profit to the volume, which will give you that thing when we do the modeling. And so easy, just read a table, sort of, when we do the modeling. So that's what we're going to do. And so we have to give our model an object name. So let's call it CVP model. So CVP model, assign it to what we are going to create. So we know what to do. We imported pandas because it's pandas which are going to help us create that kind of tabular model. We imported it as PD. So PD dot, and there's a function in there called data frame. These things are just repetition for revision. You know them already. And we're going to create the table in the dictionary form. So we have a table heading, and then the data under the heading, that kind of style. So in the meantime, we have, let's say, volume. You can use the word quantity, but I prefer to use the word volume so that it is consistent with the topic, cost volume profit analysis. Okay, so in here, I want to generate under this column. So this is the column name. And I want to generate under this column series of volume or quantities. I want to do it like 10, 20, 30 in steps of 10. Of course, you can do it 1, 2, 3, 4, 5. It doesn't matter. So let me use NumPy to generate some figures. So np.arange, and then I'm going to generate from 0 to what? So let's say 500. Well, it's too much. No problem, to 500 in steps of 10. And when I'm done with this, so this is one column table, sort of. We do it first this way because the rest of the columns depend on the creation of this one. So I'm coming outside this table, which is just one column table of the volume, and say that CVP model, and then this then tells pandas that I want to find a column on the CVP model table. If it is there, maybe you want to modify something there. If it is not there, create it, sort of. So all the ones we are going to do like this are, at the moment, we have only one column. So all the new ones are going to be created from scratch. So what should we create? So let's say total revenue. And total revenue will be, the values will be generated. So this is the column name, and the values will be generated as CVP model with the column, model with the column volume times selling price per unit, which is a variable we have created here. Okay, then we come down again. Let me copy this because we will be modifying the columns from the same style. Sorry. So now we want to create, we have created total revenue. So now we have two columns, volume and total revenue. So now when we actually create a table in a data frame form, you will see two columns. One is volume and the corresponding total revenue. The next column we want to create is called, let's call it total variable cost, because we have variable cost per unit and the volume is here. So we want to know what the total variable cost. It's good for us to know, okay, this is the volume we are doing. When we do this volume, this is the corresponding total variable cost. It's good for you to know that information as a business person. And that's the column name, and the values generated as the volume times variable cost per unit. So we only change something small here. Variable costs per unit. So we are done with that column. We come to the fourth column. So we have volume, total revenue, total variable cost, 3 columns. So fourth column, also created in the same style. Let's call it total. So after total variable cost, maybe total fixed cost, which is already created here as a variable, but we just want it to be part of the table so we have everything together. So total costs, no, total fixed costs, which is equal to the variable we have already created. So we are just linking it to pull the values from there. Okay. After total fixed cost, we can create total cost. So we have a total variable cost. We have a total fixed cost. The sum of the two will give us total cost. So we are creating another another column called total cost, which is the sum of total variable costs and so here we'll change to plus and total . total fixed cost. Okay, so that's how we generate the values for this column. What again can we do? We also want to know the profits. So the new column is profits. Even before profits, we can do, okay, let me finish with the profit and we do. So we have the profits will be CVP dot total revenue. If you don't understand anything, please, you can pause me for me to explain. Total revenue, and here will be minus CVP model total costs. So maybe before the profit column, we will even want to create another column called contribution because it's so important statistic. So maybe total contribution because we are the total level. Contribution. Total contribution is equal to CVP. What's the formula for contribution?
Oh,
So it will be revenue minus total variable cost. So total revenue. If you don't understand anything, please, it will be good to ask. Total revenue minus total variable costs.
which kind of Zoom?
Total variable costs. Okay, so we have created, this is simply the model. We have created a model where with a given volume, with a range of volume from 0 to 500 in steps of 10, we have calculated the total revenue, we have calculated the total variable cost, we have calculated the total fixed costs, we have calculated the total costs, we have calculated the total contribution, we have calculated the total profits. We can study all the analysis we did in class from this table. One, please, if you are not contributing to the class, put your microphone off. So we can study from the volume what profits we are getting and some other statistics. For example, we can study from the volume and look for where profit is 0. So that is the volume that makes us break even. If you have an idea of some profit in mind, we can go and look at that profit and trace it back to the volume and say, okay, this is the volume that will give us this profit, given the cost at which we are operating. So let's create this and see if there is no typing mistake. So let's go and read. Module NumPy has no attributes. So a range was wrongly typed. Okay, so there is G here. Let's run it again. If this is the only problem, then we are okay. Variable costs. Okay, so look at a variable. The positions of I and A are transposed. So we just need to go, that's line what? Line 6 of the code. Okay, I didn't even show line, so I can find it. Variable costs here. And that is how, sorry. So I don't think it's this one, maybe it's somewhere else. Variable. This one. Yes, here. Okay, good. So this is where the mistake is. Yeah. So this is how we learn from the mistakes. That's what I was telling you. Just feel happy that you are getting the mistakes, because this is where you will learn things from. Data frame object has no attribute variable costs. Okay, so we didn't say variable cost, we said variable cost. We said total variable cost. Let's read here. I'm going to color it where the mistake is coming from. This line. Okay, which reads, we are creating a column which is called total costs, and it is a sum of total variable costs. Okay, so you see total variable costs here, but here we didn't bring the total. So the program doesn't know exactly what we are saying. So total underscore. I guess this should be the only mistakes. Still more, data frame object has no attribute fixed cost. Fixed cost. I think it was total fixed cost rather. So we have total fixed costs. So where we use total fixed cost somewhere and maybe we didn't. Okay, so here. Total underscore. Okay, so all the mistakes are corrected now. And then we can visualize. We can, call the table and see. So we can do CVP model. Let's see the first 5 rows. So dot head. So it looks something like this. So maybe we can take some time and look at this. This is the same as the things we were doing in class. So you look at the volume, 0. So when we produce 0, our total revenue is 0. And it makes sense. If you have not produced anything, you don't have any revenue. Because what are you going to sell to make the revenue? Okay, this is not even about production, it's about sales. So if you have sold 0, you have 0 revenue. That's common sense. And then your total variable cost is also 0, because the total variable cost is generated from the volume. So if there's no volume, there's no total variable cost. And of course, your fixed cost, it doesn't have anything to do with the volume. So it stays at 500, as she gave us here. And then your total cost, which is the sum of your total variable cost and total fixed cost, will be 500, because total variable cost is 0. Added to total fixed cost of 500 will give you the same 500. Total contribution. Contribution is given by the formula revenue minus variable cost. So at this point, you don't have any contribution because you have no sales yet. And your profit is negative 500. Your profit is the fixed cost you have incurred. You have no contribution to recover this. And when you sold 10, now let's look at it. Your revenue is now 100, which is simply 10 times 10. And then your total variable cost also moves with the volume, which is in this case 5 times 10. So 50. The total fixed cost doesn't have any relation with the output, so it stays the same 500. And your total cost is the sum of your total variable cost, 50 plus total fixed cost, 500, 550. Your contribution is your revenue of 100 minus your total variable cost of 50, and then your contribution is 50. Now, this contribution will contribute towards the recovery of your fixed cost of 500. So you now have your fixed cost down to 450. Sorry, yes, your fixed cost down to 450, which is the same as your profit. So as we discussed it, you have to see the relationship, because questions could be set easily from these dynamics. And if you don't really have control over how they play out, you might struggle to get the correct answer. When we come to selling 20 units, this is the picture. And so on and so forth and so forth. If we say, let me do like dot head, and let me say 10. Well, let me see 20 and see if you can get 20. Okay. So when I expand to see 20 rows of the table, then you can appreciate it better. So when we were selling more and more and more, our losses were reducing until here, when we sold 100 scrunches. Then we generated enough revenue, 1,000, to pay for all of our costs at that output, which was also 1,000. And therefore, our profit is 0. And it's also fascinating to identify that at the break-even point, your contribution is exactly the same as your total fixed cost. Yes, your contribution is equal to your total fixed cost. So that contribution recovers the whole of the total fixed cost. That's why you have profit of 0. You have to understand these dynamics because I can quiz you easily from these things. And now let's see what happens. If, I think then I remember the name, she says she's Ifwa. If Ifwa sells 10 more above 100, she now begins to get something as positive profit. But she gets 50 cedis. So as she sells more, then the profit increases. So this is like the borderline as the break-even point. So we have done, I remember we wanted to know, okay, if she wants a profit before tax of, what was it? I think a profit before tax of 1,000. She even said she wanted 500. I said it was small. A profit before tax of 1,000. How many quantities should she sell? So now let's try to find it here. It is sometimes not too sensible for you to show the whole data set, assuming this is like maybe 1 million, or it can even be about 10 million rows, depending on the data you are working with. It will be crazy to want to show the whole of it. You can even crash your system. So by default, Python shows you few of them. You just want to know how the data looks like. If I had not done head and I had just called the whole of the data frame like this, it would have showed me, okay, this is not too plenty. I think we have about 50. So it just decided to show all of them. If the data set is so big, it will just show you the first 5, kind of bridge it, collapse all of the rows in the middle, and come to show the last 5. So first 5, last 5. That's enough for you to know the structure of the data sets. So this one is not too large, so we can study the whole of it. So let's see. If she wants 1,000 profits, we calculated in that class that she needs to sell 300 scrunches. You can go back to your textbooks and see it is there. Or you can use the statistics here to confirm the same thing. So this is how you model it. You can model it for large, large values for the volume variable, the volume column. So we can even increase this one we just did. What was the code? 500 instead of 10. We can do 1,000, 2,000, 3,000, even 100 million. And it will generate it. To generate it and help you to experiment with all of these values for the volume and how they tell you about your profit and other statistics like your total revenue, your total costs, contribution, and stuff. Any questions so far? Any questions? I want to hear your voice, please. Any
No,
questions?
no, sir, please.
Okay, so now that's it about the modeling. The next part and the concluding part is how we visualize this model. In most cases, not in most cases, I mean, it's a normal thing with us humans when you want to make sense from this kind of numbers, especially if it is large data set, it becomes a bit struggling for you. So we can compress these plenty numbers into some visuals, which will kind of bridge everything, compress everything for us to see them in pictures. And that's something that's very good. And in your textbooks, you have those kind of pictures showing it. So let's see how we do the modeling. I mean, the graphical modeling. So first of all, what I want to do is that I want to set the volume as the row labels. That will make you appreciate the graphical modeling better. So let me do CVP model dot set index. So that's a piece of function that helps us to do that. Dot set index. It is set underscore index. And this one takes an input, which is a column. So I'm going to do volume. I'm going to set the volume as the row label. So let's run and see. Okay, so this is how it will appear. Now our volume is the row label, which makes it so straightforward because this is our volume and it corresponds to the rest of the variables. But this is just a view of if we do it like this. It does not replace the original table. So to make it replace the original table, we can set the table name against this one, or a simple way to do that is to use this keyword in place. Set that keyword to true. So in place equals true, and the true should be capital T. So when we do it like that, then it has replaced the old table with this modification. So we now can call CVP model and see how it looks like again. CVP model. This time around, I just want us to see just the first 5 rows. Yes. So now let's do the visualization. I just call matplotlib. We imported it as PLT. So PLT plots. And plot what? So many ways of doing this kind of visualization, but the main one is where we want to see the interplay of our total revenue and our total cost. Because one of the ways to determine one of the key things we want to actually determine, which is the break-even point, is to plot the total revenue series against the total cost series. And where total revenue is equal to total cost, where the two lines cross themselves, that is where break-even is born. So that's the kind of thing we want to do. From the figures, this is where you see where the two are where the two intersect. And how you see that they are intersecting is that they have the same values at that point. 1,000, 1,000, then the break-even point is born. We'll see it how it shows up graphically. So now let's plot the various series. You can plot them individually and then let them play together and see how the picture emerges. So in the meantime, let us do plt.plot, then CVP model dot total revenue. if you want to see this, okay, let me give it a label. So label equals total revenue. If you want to see this, you will see it. This is it. It's a total revenue series. These values you see, these values, total revenue, from 0, 100, 200, 300, blah, 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 up to this 4,900. This is how it features. This is how that column features graphically. It tells you the values are ascending. They are increasing as volume increases. Total revenue increases as volume increases. That is a common sense thing. And that is how you see it graphically. Now, let me add total cost to it. So PLT dot plot. And then let me be lazy a little bit. Copy this because I'm going to use most of the features. CVP model, and this will be total costs. And I want to give this label, give the label total costs. Okay. So this is the picture that emerges. So we see that, okay, now let me do legend so that we can see. So PLT dot legend. So we can have an interpretation for the graphs. So the blue one is total revenue. The orange one is total cost. And you can understand how the figures we are seeing in this table are manifesting themselves in charts. So now you can see that total revenue starts from the origin, but total costs starts not from the origin. I think this is about half of this thing, which is about 500 here. And from the beginning, total costs is lying on top from this region. Total cost is lying on top of total revenue, which means total cost is bigger than total revenue. Okay, so when someone lies on top of another person, the one on top is bigger. Great. So, but this doesn't last forever. As they are moving, it goes to a point where each one is not lying on any other person. They are just at the same, they are at par. That's the break-even point. And beyond that point, total revenue now begins to lie on top of total cost, which means total revenue is bigger. And that's where we begin to see profits. So this smaller region here is loss region because cost is always bigger than revenue. And beyond the intersection, revenue is always bigger than cost, and that's where you get profit. So this is a traditional CVP chart, which can help you explain everything CVP. Any questions so far? And you can readily see that this intersection actually corresponds to this one. Or you can test. You can programmatically even test for these conditions of break-even and so on and so forth. So let's try to do some of the codes to see. First of all, when we want to test the break-even condition using a code, what we want to check is that, okay, this column, CVP model, dot total revenue. So it's like we are asking a question. CVP, or let's say total revenue. You can forget about the CVP. It always needs to be there in your code because this total revenue is an attribute of the table, and you can't call the attribute without the table. But once we understand what we are doing, the CVP is the table. We are actually using the column. So total revenue equal to, that is the actual equal to. The one equal to is just an assignment symbol. So is it equal to this thing? Is it equal to total costs? So it is some form of logical testing you are doing. Actually, this is some form of relational testing. Is this equal to, is it less than, is it greater than? They are kind of relational tests. So in Python pandas, when you do this kind of code, what it's going to do is that it is going to return results of true and false across all the rows. So it's going to test here. So when I take this row, I'm going to check total revenue, which is 0, and total cost, 500, and then it will return result false because this is like a question and the answer is false. It will do it across all of them. Let me run it for us to see. Okay, so you will see false, 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 and then where it is true, you see true, and the rest is false. But this is not the kind of information you want. So you kind of put this kind of question, okay? The whole of this question, let me cut it. You filter the table with this question. So this is how you do it. You say table, which is CVP, model, and then you say CVP model. I want you to extract your rows based on this condition, based on where CVP model total, based on where total revenue is equal to total cost. And then when you run it, it will just filter the whole table and show you the portion of the table where this is true. And this is the portion it shows us. You say, okay, this is that slice. So this is also called slicing in Python. So it has sliced the portion of the table where this condition is met. Volume is 100, total revenue 1,000, total variable cost 500, total fixed cost 500, total cost 1,000, contribution 500. And you have to study these figures. They speak something. When profit is 0, total revenue is equal to total cost, that is okay. But another thing is contribution is also equal to fixed costs. That is why when you subtract your fixed cost from your contribution, it's the same as subtracting your total cost from total revenue. And I'm also seeing that total variable cost is equal to total fixed costs. Well, I will have to think about it, why the two, whether it's actually speaking something, or sometimes just by coincidence they are the same. We can also check with another dimension. This one we use total revenue equals total cost. You can also check with the idea of profit equal to 0. So CVP model dot profits. So actually what you're saying is profit equals 0 is a relational test. And when you do this, it will bring a Boolean result of true and false across all of these rows. Check this profit is equal to 0. So false, 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 false. It's only here that it will classify as true. So what you can do is you can put this one inside a table. You can kind of slice the table based on this relational test, which will mean, let me cut it first so that you can see. So I'm going to do CVP model. And then this is slicing notation. And I put this one inside and run it. So let's see what the problem is. Data frame object has no attribute profits. Let's see. Total profit. So sorry. So here is total profit. That is how I labeled the column. So I can use a different name. Okay, so it gives you the same kind of information. It slides the same portion of the table. Any questions so far? Any questions?
No, please.
No, sir.
Okay. Then one thing probably we can do, maybe you may want to add some line which is actually pointing to the 100. You can do, we have done some before, you use the AXV line function. So I can do, maybe I think I need to add it to the plotting. So I just want to add a line which passes exactly through the point of intersection to come and point to the quantity variable. Of course, you can also do some across, but mostly that's not where the point is. For now, we are looking at the quantity, the break-even quantity. So what I'll do is that I'll do PLT dot AX, if you like, think of AX as axis. Axis is like the whole of the canvas on which we are drawing. AX V line is like a vertical line. AX V line. And then it takes input. I can put 100 there, but if you put a constant value there, it doesn't make the programming responsive because we can change the parameters or the variables here and the position of the break-even can change. So usually you want to program it such that it will respond to any changes that will happen. In that case, what we can do is that we already know that we already have done this code, and it brings us this table. Inside this table, what we want is this line. We want the break-even slice and then the corresponding volume. So we can copy this code. We can copy this code and pass it to the AXV line as an argument. But the point is, see this code. It brings a whole table. And we want a line which corresponds to a value 100. So this is the whole table. When I do dot index, let me do it here and for us to see. Dot index, it is something like I want to extract the index of this table, and the index is this. Let me run and see if it will. Okay, so we see index 100 here. So this is what we want to extract. So that's a value. So I can put here dot, I just hope it will work, dot index. Sometimes you just need to experiment a little bit and see if you can get the results. Okay, so dot index, so it has extracted the index of it. It means that anytime the CVP, I mean, the break-even changes, for example, I can go and change some variables in here. Let's say the fixed costs, she said her rent was some value, and then when we did a proportionate extraction, the portion that the company should pay is 500. Let's say now rent increases and it is 1,000. It's just for an experiment. Now we have to run everything again because the values are going to change. And now let's see. I think I should have even, let me do this one first. Let me come and run this one so that we see the break-even. Now the break-even is 200. It means that if you had done a hard code of putting 100 here, Now the break-even was shipped and the line is somewhere else. So now let's run this and see if it will be that responsive. Yes, it is that responsive. It is moving and it's just showing that, well, if things change like we said, fixed cost is now 1,000 because rent has increased, then this is our new position. And then the chart, the visualization reflects that. Okay. Any questions so far?
No, sir, please.
Okay, so
No.
this is where, yes, go ahead if there's a question. Otherwise, I think this is where we will end the modeling of the single product CVP. If there is any other thing that we have to learn in addition to what we have done today, we will do it subsequently. Thank you very much for your attention.
Hi. Hello.
Thank you very much, sir.
Thank you, sir.
Yes, please, if you have a question, just go ahead and ask.
So please, with some of us, our network wasn't really good, so I wanted to ask
So,
if we'll be able to get there.
sure, I think the video is even automatically streaming and being recorded on YouTube. So you can go to the
Okay,
YouTube
sir.
channel, it will be there.
Oh,
And you
thank
can play it over and over and
Okay,
over to make sure
okay, thank you.
you have gotten it. Okay. Thank you.
Okay, sir.
Oh, okay, sir. Okay, sir. Okay, sir.
Thank you.